we have the unit circle here, and you'll recall that it's called the unit circle because the radius is always 1. So that means here at 0 degrees, this point on the unit circle would be 1, 0. Up here at 90 degrees, which is pi over 2 in radians, we'd have 0, 1. At pi, we'd have negative 1, 0. And at 3 pi over 2, it's 0, negative 1. So we're going to be plotting some points and building some triangles. And we're going to be finding missing lengths and ratios using Pythagorean theorem. So here's our first question. If cosine theta is negative 5/7, what are the values of sine theta, there's a correction there, and tangent theta? Okay, so let's think about what that means. Cosine, we know, is the ratio of the adjacent side to an angle to our theta over the hypotenuse of the triangle. So in this case, the adjacent side, we're going to say, is negative 5. And whenever you have a negative in front of a fraction and it's assigned a trig value, like a trig ratio, you're always going to put that negative with the top number. The hypotenuse, or the bottom in this case, is always going to stay positive. So this means that, remember, our cosine correlates with our x value. So this means that we're going to have to go 5 to the left, and then we don't know how far up we're going to go, but our hypotenuse is going to be 7. So let's fill those two parts in. So from 0, 0, so starting right here, I'm going to go 5 units to the left. And that's because my cosine is negative 5. That means I'll land right here. And then I don't know how, let me fill that line in there. That's the side of our triangle, right? We went negative 5. And then I don't know how high I'm going to go, but I do know that my hypotenuse is 7. So I'm just estimating that the point would be somewhere around here. And this is, oops, let me make that a little straighter. This is the leg that we don't know, so I'm going to call it A. I'm going to use Pythagorean theorem to find A. So we know that A squared plus B squared equals C squared, and we fill in what we have. A squared plus, it's really just 5. I'm putting the negative just to, clarify that we went 5 to the left, but it's really just 5. And that's going to take care of itself right here, because when we square it, it becomes positive. And I keep going. So A squared is equal to 49 minus 25, which is 24. So A is equal to the square root of 24. Now we can simplify the square root of 24. You may have to, or you might not, but let's just simplify it, just in case. Because the square root of 24 is the square root of 4 times the square root of 6, which is 2 root 6. So that's our value of A. That's this missing side that we were looking for. So we know that that's 2 root 6. So I'm going to fill it in right over here. And now we can find the values of sine theta and tangent theta. So this is our theta. It's always going to be the angle that is in the triangle that's nearest the origin. So if we wanted the sine, for sine, it's going to be opposite over hypotenuse. So our opposite side is going to be the one that we just found, which is 2 root 6, over the hypotenuse, which is 7. So there's our sine. And then lastly, we have to find tangent. And tangent is going to be opposite over adjacent. So our opposite side, again, is 2 root 6. And our adjacent side is negative 5. Now, always be careful, because in this case, we went up. to get our point. But really, because it didn't specify, that means we could have also gone down to get to this same point, right? Because it didn't specify whether or not the sign, and so this case, this would be 7, and this side here would be the 2√6 side, right? And this would be 5. So it didn't specify, so really it could be either, because both of these angles have a cosine of -5/7. Now, in this case, if I were to do the red triangle instead, then my sine would be negative, and my tangent would become positive, because I'd be doing a negative over a negative. Okay, so because they didn't specify, it really could be either. Usually, we'll see in some of the other problems, they specify and give us a range to look at, or let us know if certain values are positive or negative. Okay, so we've got one like that here. It tells us the cosine, and it also gives us a range, saying that theta is between pi/2 and pi, which means it's between here and here. So it's in quadrant 2. And what are the values of sine theta and tangent theta? Now, this value of cosine should look familiar to you if you have the unit circle in front of you, or if you're in the process of memorizing the unit circle, because this is one of the angles that we study in the unit circle. It's one of the multiples of 45, because remember we looked at, let me just draw them in. A few lessons ago we looked at 45 degrees, and then we looked at 135, right? We went all the way around, bisecting that 90-degree angle in each quadrant, and we looked at those points. So since we know that we're in quadrant 2, that means if you picture the unit circle going right through here, we're looking at this point on the unit circle. And because this is a value that we're familiar with on the unit circle, you can look it up. Let's see what it would be in radians. So this is pi/4. Then this would be 2 pi/4. Then this would be 3 pi/4. So that's the angle that we're at, 3 pi/4. And I could fill the circle in, or what a quarter of the circle might look like. And you can just look this up, because on your unit circle, you'll see that you have an x and y coordinate for this point, and it's -√2/2 and +√2/2. So that means we have the cosine. That means that the sine is the y value. Sorry, that would be positive, right? Because my sine is positive in quadrant 2. And then my tangent is just going to be sine over cosine, right? So y over x, which is just going to be this over this. So anytime I'm putting the same number over itself, it's just 1, but then my bottom is negative, so that's going to give me -1 for my tangent.